there! This is Mathematics Alive Geometry Lesson 8, Proving Triangle Congruence. Triangle Congruence Definition 1. Congruent triangles. Two triangles are congruent if their corresponding parts are congruent. The acronym for this is CPCTC, which means corresponding parts of congruent triangles are congruent. So in these two triangles, we have the marked parts are the corresponding parts. So we have the sides AB corresponding to side DE and side AC corresponding to side DF and side BC corresponding to side EF. And for the triangle congruence here, we have triangle ABC is congruent to triangle DEF, which means that the angle A corresponds to angle D, and angle B corresponds to angle E, and angle C corresponds to angle F. Properties of triangle congruence. Triangle congruence has the following properties. We have symmetric property, reflexive property, and transitive property. For symmetric property, if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. Then, reflexive property, a triangle is congruent to itself. So triangle ABC is congruent to triangle ABC. And then transitive property, if triangle ABC is congruent to triangle DEF and triangle DEF is congruent to triangle GHI, then triangle ABC is congruent to triangle GHI. Here are the conditions that guarantee triangle congruence. First, we have the side-side-side congruence postulate, or the SSS congruence postulate. If three sides of one triangle are congruent respectively to three sides of another triangle, then the two triangles are congruent. So we see here the correspondence between the congruent sides as marked, and we see that these two triangles are congruent. Next, we have side-angle-side congruence postulate. If two sides and the included angle of one triangle are congruent respectively to two sides and the included angle of another triangle, then the two triangles are congruent. Look at the figure below. We have the sides. The two sides here are including the corresponding angles, which are also congruent. So we can say side, angle, side of one triangle are congruent respectively to the side, angle, and side of another triangle. Thus, we can assume the congruence between the two triangles. Next, we have the ASA congruence postulate, or angle-side-angle congruence postulate. If two angles and the included side of one triangle are congruent respectively to two angles and the included side of another triangle, then the two triangles are congruent. So we have two angles which includes the common side or the corresponding side. So we have ASA congruence between the two triangles. And lastly, we have the SAA congruence theorem. If two angles and a non-included side of one triangle are congruent respectively to two angles and a non-included side of another triangle, then the two triangles are congruent. So we have two angles here and the non-included side of the triangle congruent respectively to the two angles and the non-included side of the other triangle. Thus, the two triangles are congruent. Now let's focus on right triangle congruence. The following theorems give sufficient condition for congruence between two right triangles. We have the leg-leg congruence theorem, or if the two legs of one triangle are congruent respectively to the two legs of another triangle, then the two right triangles are congruent. We can assume this because by SAS congruence postulate, we see that the right angle here are already assumed to be congruent. So we can prove the congruence of these triangles by side, angle, side. But since they are both right triangles, then we can just focus on the two legs. So we have the LL congruence theorem. Then we have the LA, or leg acute angle congruence theorem, or this is the equivalent of ASA. If we look at the leg and the acute angle of one triangle congruent respectively to a leg and an acute angle of the other triangle, then we consider the right angles on both triangles. We see that we have an angle side angle congruence. But since these are right triangles, then we can just focus on the leg and the acute angle. Then we have the hypotenuse leg congruence theorem, or the high L congruence theorem, which is equivalent to SSS congruence postulate. So if we look at these two triangles, we have two sides of one triangle correspondingly congruent to the two sides of the other triangle. And since they are both right triangles, we can assume that if two sides are already congruent, then the third side will be congruent by Pythagorean theorem. And we have the hypotenuse acute angle congruence theorem, or the high A congruence theorem, which is equivalent to SAA. If we look at the form of the congruence, we have the hypotenuse here and the acute angle, and then we assume that the right angles are always congruent, so we have the SAA congruence for these two triangles. But since we're now focusing on right triangles, we can just assume the congruence between the hypotenuse and an acute angle is enough or sufficient condition for right triangle congruence. Proving triangle congruence by deductive reasoning. Deductive reasoning starts with some accepted facts, definitions, axioms, postulates, and theorems to prove the specific situations. It is important to learn how to prove in mathematics to enable the student to go through the process of reasoning that ancient mathematicians went through. In so doing, one gains skill in deductive reasoning and appreciate both the process and the result. Proving triangle congruence. Proving triangle congruence is like proving a case in court. First, we lay down the evidences in a logical order. Then, when we have gathered enough evidences to guarantee triangle congruence, we can make conclusions that the two triangles are congruent and the corresponding parts of the two triangles are also congruent. Now, we're ready to prove. Let's start proving.
Now we are ready to prove triangle congruence by deductive reasoning. Number 1, we are given these two triangles and AB is congruent to AD. So for our statements and reasons, I will just lay down all the evidences that these two triangles are congruent, and those are the given facts. So AB is congruent to AD, given. Then BC is congruent to CD, given again. Then another obvious part which is congruent to itself is AC is congruent to AC. So this is by reflexive property. Reflexive property of congruence. So we have three sides which are already congruent respectively. So we can use the SSS congruence postulate. Therefore, we can conclude that triangle ABC is congruent to triangle ADC. For number 2, we are given AB is congruent to CD. These parts are marked congruent. And then AB is perpendicular to BD. So this is perpendicular to this line segment. And also CD is perpendicular to BD. This is perpendicular. Therefore, they form right angles at the foot of the perpendicular. So we can use the theorem for right angles, and we can also use the postulates that we already discussed. So for our statements, we have the given AB is congruent to CD. And then AB is perpendicular to BD and CD is perpendicular to BD. It is also given that E is the midpoint of BD. So we have here a midpoint. Therefore, this line segment is divided equally into two equal parts. So we can also mark these parts as congruent. So for this fact, AB is perpendicular to BD, a right angle is formed, and CD is perpendicular to BD, another right angle is formed. Therefore, angle B and angle D are right angles. And reason is right angles are formed at the foot of the perpendicular. Then number 4, angle B is congruent to angle D because they are right angles. So for the reason, all right angles are congruent. And then, since E is the midpoint of BD, then we can say BE is congruent to DE by definition of midpoint. So if you look at the figure, we have one side, one angle, and another side. So we can use either assess, congruence, postulate, or we can also use leg congruence theorem. So we can conclude that triangle ABE is congruent to triangle CDE by SAS, or by LL. And the second part that we are going to prove is angle 1 is congruent to angle 2. If the two triangles are already congruent, then the corresponding parts are also congruent. And angle 1 is a corresponding part of angle 2. Therefore, angle 1 is congruent to angle 2 by corresponding parts. Corresponding parts of congruent triangles are congruent. CPCTC. For number 3, we are given AC is congruent to BD. AC and BD are marked congruent. And then angle C is congruent to angle D, the first pair of congruent angles. And we observe that this angle 1 and angle 2 are vertical angles. So they are our second pair of congruent angles. And if we observe, the figure can already be assumed congruent because you have side angle, angle. And we will use the SAA congruence theorem. So let's lay down our statements. First, we have AC is congruent to BD given. Angle C is congruent to angle D given again. And then angle 1 is congruent to angle 2. Vertical angles are congruent. Or you can say vertical angle theorem. And we can now conclude that triangle ACE is congruent to triangle BDE by SAA. And the second part that we're going to prove is AE is congruent to EB. AE is congruent to EB. We have a question mark here because that part is still to be proven. But now, we can assume that these two are already congruent because the triangles are already congruent and corresponding parts of congruent triangles are congruent. C, P, C, T, C. For number 4, we have here an overlapping figure. We have triangle ABC overlapping with triangle BAD. And we're going to prove that triangle ABC is congruent to triangle BAD. And also BC here is congruent to AD. But it will be easier for us to understand the relationship between the parts if we redraw the two triangles and remove the overlap. So I redraw the triangle. Here is triangle ABC and here is triangle BAD. Okay. Given that AC is perpendicular to AB, we have a right triangle or a right angle here. And also BD is perpendicular to AB, so we have a right angle at angle B. So for our first statement, we have the perpendicularity given, and then angle A and angle B are right angles because right angles are formed at the foot of the perpendicular. And then angle A is congruent to angle B because all right angles are congruent. Then we can assume also that AB, which is the same line as the AB here, AB is congruent to itself by reflexive property, number 4. And then we're given that angle 1 is congruent to angle 2. So we put it here. And let's mark the parts. We have here an angle, and then a side, and then another angle. And we have enough evidence to prove that the two triangles are congruent. Therefore, we can say triangle ABC is congruent to triangle BAD by ASA, or ASA congruence postulate. And for the second part, BC is congruent to AD because they are corresponding parts of congruent triangles, and therefore they are congruent.
Some people ask, why do we have to prove theorems in geometry, which were already proven long ago by ancient gurus in mathematics? Proving exercises our thinking process and gives us insights into how early mathematicians think and how they came up with those theorems and formulas that we are privileged to use today. Let me share with you a quotation from Blaise Pascal. People are usually more convinced by reasons they have discovered themselves than by those found by others, or second-hand information. So please like, share, and subscribe to this channel by clicking the button below. Thanks for watching and happy proving!